So I think you guys have to decide within your company itself. So once you decide that, then there is actually this training program is of 25 sessions. The 25 sessions are 25 sessions are there. So this will cover n number of algorithms of demand forecasting.
Okay.
So there are a lot of algorithms. A lot of algorithms are there which we can cover. So that has to be decided within you people. So once you decide that, then we will be giving a fully structured training program on demand forecasting.
Yeah, got it.
So we will start the program now. So I'll be sharing my screen. So let me know, guys, if you're able to see my screen or not. So you have any more team members left to join? So we can wait some more time for them.
I think we're done.
I'm just facing some technical problem here. Okay, so are you able to see my screen? Because now I think we are in a position to share.
Yes, Krish, it has come up. I can see. Ananya this side.
Hi, Ananya. So can we continue from the yesterday's session, Ananya? Can you share your screen and we'll continue from there?
Sure. So should we wait some more time for Sapna, or should
Swapna is not joining? She is not joining.
Okay. So I'll be sharing my screen. Please let me know once the screen is visible. So yesterday's class we had mostly discussed around that simple exponential smoothing. It was kind of a deviation from the crosstown that we were doing. So should I open from the crosstown file?
No, we will start from the multiplicative model, multiplicative and additive model. So which will.
All right. So, Krish, I could not complete that homework that we had discussed. So I got caught up with the crosstown part. So I'll complete this and share.
Okay, no problem. So let's give give a background information before we move forward. Just give a background information. What is multiplicative trend? What is additive trend? How that differs? How it is? Can you just give some background information on that?
Sure. So just to give the context, I'll quickly open up the tent. So if I'm looking at any forecasting model, I'll call that F. It can be decomposed into two components. One is the systematic component, and then we can have the unsystematic component. So unsystematic component would represent the randomness. We call that as noise that cannot be modeled. The systematic component can be modeled and it can be decomposed into three further categories. We have the level, we have the trend, and then we have the seasonality, S. Now, depending on whether a certain series has the trend component or not, seasonality component or not, we can recommend the appropriate model. Now, coming to these components, that is trend and seasonality, we can either have additive trend or multiplicative trend. In terms of the seasonality, we can have either the additive seasonality or multiplicative seasonality. Now, what do we understand by trend or seasonality? I just try to give a visual demonstration. So suppose we have a time series like this.
Okay,
Let
so
us
what
consider
is
the very-
just a minute. What is the x-axis here and what is the y-axis here?
Yes, Krish. So the x-axis is obviously the time because you're measuring the values over the time, and the values I will represent that as a function of time as say Vt. So if I'm looking at a horizontal line like this, which is not changing with time, we can say that this is devoid of the trend component. Next, if I look at a violet line like this,
Okay, but in general term, very simple term, what is Vt? So just can you express that what is Vt? The y-axis you have Vt, right? And
yes. So Vt, we can say that this is the value that we're measuring over time. So if I'm looking at a shoe manufacturing company, it can consider the sales as Vt. So if Vt is confusing, I can simply replace that by S.
okay.
Now, if this is my shoe manufacturing company, I'll call that say M over here, which is manufacturing the shoes. It in turn can procure the raw materials from a vendor V. So vendor V can also consider the raw materials that they're supplying to M in a similar function of time. For the sake of simplicity, we can consider it to be the sales of this shoe manufacturing company, which I have called as M.
Okay.
Is this clear or?
Yeah. So why we need, sorry, that's very clear. So we have our y-axis as sales because that is an output, right? Generally, we try to put the outputs which we are measuring or outcome which we are measuring on the y-axis. All right.
Yes.
Now, why we are using time as the time on the x-axis? What is the need of putting time on the x-axis?
Was that a question for me, Krish?
Yes, for you. What is the need of putting time on the x-axis?
All right. So that's because we are that's my understanding that we are considering time as the independent variable, and in our mind we are thinking that the sales is varying with time.
Okay.
So
So
sales being the dependent variable and T is the independent one.
Okay. So time is our input variable, right? That's an independent variable. Okay. So what we are saying, the sales depends on time, right? Sales
Yes.
depends on time. So sale is dependent variable because that's why we say sales depend on time, and time is an independent variable. Time is not dependent upon sales, but sales is dependent upon time. So sales is the output, time is the input. So what we want to know that as the time increases, is the sales increases. As the time increases, is the sale decreases. As the time increases, does sales increase and decrease for a period of time? So what we want to know? We want to know three or four things. First is, if the time increases, can you put number 1, 2, 3, 4 on the x-axis? Like,
Sure.
okay, can you put some values on the y-axis, like 10, 20, 30, 40, something like that? Right? So what we are saying, suppose if at time t1 we have a sales, for example, 10, can you create the coordinate 10 and 1 and 10? So 1 and 10. That's the first. That's a 1 and 10. Means at time 1, suppose we have time 1 means let's say January. In January we have a sale of 10 units. In January, let's say February. In February we have a sale on 20 units. So can we create a coordinate again for? So just combine them, x and y axis. I think you have to go create a y. Yeah. Also you have to, yeah. Now just similarly for January, March we have a sale of 30 units. Similarly, April, we have a sale of 50 units. So what are we trying to do is that we're trying to understand the pattern of sales as the time is moving up or as the time is increasing. So we want to understand the pattern: January, February, March, April. So as we are increasing the time, we are trying to understand what is happening on the sale. And if we are able to see any kind of pattern, if you're able to see any kind of pattern as the time increases, if you see any kind of pattern, then we can able to create a model based upon that pattern. So forecasting is all about, if you are doing any kind of predictions, if you got any kind of predictions, the predictions can be done based upon the patterns of in the history. So if you just, what you have to do, you have to take the data from the history, and on the data from the history, you have to develop some kind of understanding, and that understanding is all about understanding the patterns. So if you understand the patterns, then you can model it for the future. If you are not able to understand the patterns, if you are trying to create a forecast, then the forecast is always a guesswork. You will not be able to know whether your fundamentals of forecasting are actually good enough. So when we plot a x and y, this is called Cartesian graph. Or Cartesian means K-C. Can you write the spelling of Cartesian? C-A-R-T-E-S-I-A-N. This is a Cartesian plot which is drawn between two variables. So this is a two-dimensional plot. So x is our time, which is the input. So as the time increases, y is our output. What is happening on the output? And if you are able to see some kind of pattern there, it's a very good thing for us, because as we see the patterns, we can model that for the future. If you're not able to see the pattern, then we have to work on the data further so that we can create the pattern or we can eliminate the pattern. Right? So here, if you see, this within this plot itself, the Cartesian plot means x and y axis. We will be plotting the data, and we see is there any kind of pattern which is available or which is present with respect to between sales and time. If you have a pattern between sales and time, then we'll try to understand what is that pattern. It is a trend pattern, it is seasonal pattern, it is cyclic pattern, or there is no pattern. If you're working with time series data, right? If you work with time series, means whenever we use that word time, means time is our input variable. So time is a input variable which impacts the sale, right? So how does you view time as impacting the sale? Suppose we have a season, right? If you have a good season, like if you have in your country the summer season, we will see the sales of mangoes and watermelons or ice creams will be very high, right? So when we have a season of mangoes, watermelons, and summer season as ice cream, the sales will be very high. But as we move towards the winters or the rainy seasons, right, we will not be able to see the mangoes or watermelons because they're not available. So time is impacting time here is a factor which is bringing the sales of watermelons or the mangoes or the ice creams, going high. But as you move toward the winter season or the rainy season, we want to see those things, because as it's very clearly visible that time is impacting the sales, right? So this is what we want to understand from the data, right? This is what we understand. See, it's very clearly visible here. We have a product which is mango. This will be sold. This will be produced, harvested, packed and sold in summer season only, right? It's very clear. But there are some other products which is very difficult to be predicted. There are some products which are very difficult to be predicted whether they are having any seasonal nature. So for those kind of products, we need to use the data. Otherwise, we will be forecasting without any kind of direction or without any kind of visibility. So there are some products which will have which we know that this is seasonal, and we can manage our sales. But there are some products which are not seasonal, but we have to understand whether the seasonality is available or not, and that we can only predict by looking at the data. Right? So we'll see how we can do that also. We can see that, right? So now, Ananya, can you explain what is the additive trend and what is a multiplicative trend?
All right. So I'll first try to explain visually, then I will move on to the numerical part. Second, we'll look at sales, and then we look at the time.
Yep.
So if I'm looking at a line like this, it indicates that we do not have any trend. We can contrast this with a curve like this. Quite clearly, we can see that the values are going up with time. It means that there is a trend. Now let us contrast this red line with another curve like this. So both of these are going up. This one is going up rapidly. This we can say that this is a linear trend. This one is a multiplicative trend. Now, how can we say that? So if we look at the numbers, these are like 2, 4, 4, 6, 8. So the quantum by which the sales in each time period goes up is a fixed number, that's 2. We can say that that's a linear trend. If we can compare this with a set of values like 2, then 4, then 8, then 16, so it's getting increased by power of 2, this would construct a multiplicative trend series.
Okay, can you explain the same thing on the data just we have? And also after putting data, make a plot also.
Sure. So here is a similar diagram that we have. So the serial number 1, this would indicate the time periods. So sales 1, we can see that this is 2, 5, 6, 8, 12. If sales 1 we plot, that's the orange curve, we can see that it's going up with a linear trend. The differential here is not exactly the same, since the rate of increase varies at times, but by and large it's linear. But if I'm looking at the sales 2 curve, it's similar to the exponential curve that we discussed. It's 2, 4, 8, 16. It's getting multiplied by 2. If we plot this, we can see that the rate of increase is different from sales 1. It goes up rapidly. So this one represents a curve with a multiplicative trend, while the orange one would represent a curve with a linear trend. Next figure, I have just taken a log of the sales values. But if I'm taking the log of this one, then this becomes an additive trend, because then log 2 to the power square, the 2 comes in front, the 3 comes in front. So those of us who can visualize this scenario can understand that it would be transposed to a linear series.
Okay.
So Krish, would you want me to replot these numbers that I have
Yeah,
just shown here?
Yeah, please replot that.
All right.
You can make it random. You can make it random by taking the x-axis, the time periods, equal to 2 to the power, the times 2 to the power.
All right.
2 comma, and take the 5. Yes. Close the bracket and drag. So this is a formula which we're using called power. This formula is used to create the, now it's fine. So what we have done, we have two data sets. One is a linear trend, another is a multiplicative trend, and we're going to plot the graph. If you look at the graph, see the gray line. The gray line is a multiplicative trend. It is increasing exponentially. And if you look at the orange line, this is pretty linear, straight line, right? Can you actually work on the y-axis? Click on the y-axis. No, just click only on the y-axis. Yeah, and go and what is format axis. And here you give the max difference between maximum value. It's 1200. So here the major units are 200 and 40. So create the major units is 20. Major 20. Yeah. Click OK now. Still we're getting the same issues. Okay, no problem. Let's leave it. So now, so what Ananya is trying to explain here is that how the trend we can detect, how we can actually understand what kind of trend we have, what kind of pattern we have, right? We're seeing trend in two ways. One is linear trend, other is multiplicative trend. The gray line is called the multiplicative trend. If you see this kind of pattern in your data, means your sales are behaving in this kind of mean, it's a good thing for business, right? If you have a continual increasing sales, it's a very good thing for our business, right? So if we have a continually increasing sales, so we have to model our forecast, or we have to create a mathematical model based upon this particular pattern. But if we are creating a model, if we know the sales are like this, means it is continually increasing period over period, and but we create a linear trend or a average forecast line, then that is going to be going to damage the future, and we're going to end up doing a lot of inventory issues, right? So this is what we need to understand from the patterns. So if you have a data, you need to understand the patterns, and those patterns have to be understood based upon statistical methods. And after we understand the visibility, after we understand the patterns, then only we are going to create our models. That's what we want to show. So I will share my screen, and I will show you some steps on how to work on this kind of things in a dynamic way. So I'm taking the responsibility now, Ananya, to share the screen.
Sure, Krish, I've stopped sharing.
So what I'm going to do here is I'm going to use a functionality of the Excel, which is called Power Query. So here I'm going to import the data using Power Query inside my Excel. And in case if you have any questions, guys, please do feel to ask the questions. I know, so don't shy or don't restrict yourself asking your questions. So now the second option. Now what you have to do, I have to browse my system.
Krish, just a quick question. Are we recording the session?
Yes, the session is on the recording.
All.
You'll be able to see the top, right? Yes.
Yeah, I can see that. Thank you.
So I am taking the data of sales first. I'm going to import this data inside our Power Query and create a database. The advantage of working with Power Query is that we can actually automate the entire process. We don't need to create everything from fresh. Suppose if you have a data and create a database like this inside the Power Query, so you can automate your entire forecasting process. Right, this is the data which we have, and this data considers sold to party, sold to name, material number, material description, right? Open sales order quantity, actual sales quantity, total sales quantity, right? So all these things we have in this, and we are going to transfer. I want to transport this data inside the Power Query. So here, after transporting, I am selecting this sheet name which I have to transport inside the Power Query, and then I'm clicking on load. As soon as I click on load, it is going to upload this into a blank Excel sheet where this is the loading happened, right? Now I'm going to upload one more data set inside the Power Query. Again, go to same process. So Power Query is a tool which you can use to create your data cleansing, data transformation, and creation of database. All the three things you can do in three things, and the most important thing is that you can automate the process. The most important thing is that you can automate the process. That's the most important thing which we are going to be achieving from this. And every time you want to create a new forecast, you just have to click refresh. You have to upload a new data inside your folder. After uploading new data into the folder, just click on refresh, and your forecast is ready. So so the total time of creating your forecast every day. Suppose we come to the office and we want to create dashboard. And we want to create dashboard, and you have to spend I think 3 to 4 hours or 5 hours with 2 or 3 resources to create your forecast, right? That can be achieved in 15 minutes with a single resource. That is the beauty of using the working with the Power Query. The entire automation happens. Okay, so what I did is I have transported two data sets inside my using Power Query. One is our inventory data, other is our sales data. Okay. This is the first set of the process. Now, what I have to do here is that before coming over here, I'll take you to another table. I just wanted to show the process. So the process you have seen that how we can import the data using Power Query. So I have imported one more data set inside the Power Query, and this is what the table is here. Okay. Now what I have to do is that I want to understand my data. How many patterns are visible inside the data, right? Whether this data is having seasonality, this data is having a trend, and all those things. I want to understand them. So what I'm going to do is that this is my sales history here. This is my product. This is a product. What I've done in the first column is I've combined the product code, I've combined the product description, and the customer which I am selling to. So all the three things are combined together. So I don't need to, suppose if I want to understand my sales, so I can understand my sales based upon the product, customer, and the description. So I combine this together, right? And also I'm keeping one column additional to see the product code separately. So this is solving my, I don't need to go to check three columns at one time. I can just focus on one column and I can understand what is my product code, what is my product description, and what is my customer. This is what I made my this is as per the need of the customer, and this this as per the comfort of the customer. Suppose if you want to, you don't want to have like this, you want to have the product code in different column, or the description in the different column, or you want to have the customer name in different column, that also you can do, right? So as of now, we are going to keep all of them together, and we have a product code separately because this is our unique code. So this code will be using to combine two different data sets. Suppose we want to do VLOOKUP. We don't do VLOOKUP in the Power Query. We use a different function called we different function called merging, right? We have a different functionality in Power Query, and that is called merging. We don't use VLOOKUP there. And there is one more kind of thing. Suppose you want to build relationships between two data, and you want to transfer the data from one data to another. That also we can do by using called relationships. So in Excel, when we work on the Power Query, so what we do is we can work with the data instead of using VLOOKUP, all those things. We work on all those things. We use the database functionalities, and they are called merge data, and second is called relationships. Right? When you merge data, there are various options. We feel it will see left join, right join, inner join. It's the most popular. Outer join. Right. So these are all the functionality we use to merge data when we are working in Power Query. We don't need to use we don't need to use any kind of VLOOKUP function. VLOOKUP, HLOOKUP, and all those things are they are clumsy, and we have to use some time. But as in Power Query, you can eliminate all of them by using this kind of functionality. Relationships, we can build relationships. In relationship, there are relationship called one-to-one. There's a unique fields are there. Okay, we have to build a relationship using a unique field. One-to-many, many-to-one, and the last one is the last and least desirable is many-to-many. So to understand these things, we need to provide a different training program. So this is how we can work on the Power Query. We can eliminate the use of VLOOKUP, HLOOKUP, XLOOKUP. All these things we can eliminate, and we can build these two tools. We can use these two tools to work on the Power Query to generate and generate or combine multiple data sets with very ease. Okay, and we can summarize the data. We can summarize the data with by using this kind of these two functions. We can summarize data beautifully. If we have 50 data sets, or 100 data sets also, right? If you are able to use this merge data and relationship function, and every day, if you want, and you want to use the data every day, think how much time you have to spend on 50 data sets or 100 data sets every day. It will take a lot of time, right? So once you use this merge data and relationships, you can automate your entire 50 data sets. The most important thing is that you are able to achieve the automation. And if you're able to achieve the automation, now second day onwards, so next 1 year, you will able to achieve your output in less than 5 to 10 minutes. You are able to create your data, visualize dashboards, and go to meeting, discuss everything. So just you are going to a meeting with within 5-10 minutes, you are ready with your data, and you are ready with data as well as dashboards. So you do not have to work on the 50 data sets again every day. Just click on a button called refresh. Just click on the button called refresh, and you will be able to achieve what you want to achieve within a frame of within a 5-10 minutes. This, you see, a button called refresh is here, right? This button is called refresh. So just you click refresh, this data will be updated. So what you have to do, you have to go back to the folder, right? This is a folder which let me show you the folder again. So this is my data folder. This is my data folder, and this is my data, supply data or whatever data is there. I have to upload a new data, the same name in this folder. Upload a new data or new folder, new file, the same name in this folder, and come back to this table or this sheet and go and click on refresh. What you will see? You will see a new data getting updated here. Right? It's so simple. So simple and so effective and so efficient. So you will be able to save a lot of money on your a lot of time. You'll be able to save a lot of money, and you will be getting the output in less than 5 minutes. So upload a new data, refresh. This is what we can achieve, and this is how the automation happens. So now, once we have an automation here, now I want to understand what is where is the trend, right? So what I'm going to do here is that I'm going to create a timeline here first. I'll say this is my x-axis, this is timeline. Just now Ananya have created the x-axis, right? In that we nominated that as our input. So I am going to create an x-axis in the data now. So this is my x-axis. And what is my sales here? This is my sales. This is a product. The product is 02270F, which is sold to customer, Allied Pinnacle Private Limited. Right? This is sold to this customer. And what is the sales for the August? 0. September? 0. Right? We have a sales for at January. And we have sales in the next period of January. Okay? So this kind of product which you see is very difficult to predict because this is having intermittent. This is an intermittent sales product. It's very difficult to predict this kind of model. Or we can choose this kind of model should not go for the forecasting. We can go for the make to stock or make to order. Whenever we get the order, we'll buy it. If we do not get the order, we'll not buy it. Right? But there are some kind of products which have consistent sales. Like if you look at this product, row number 92. Here, if you look at, we have almost consistent sales here. This kind of product, we need to build a forecast because we have to go for make to stock scenario. So how to understand whether we go to make to stock scenario or we should not go to make to stock scenario? For that, we have a column called frequency. So the frequency of sale. So if we see wherever we have the highest frequency, let me sort here, descending order. So in the descending order, if you see, wherever we have sales of close to 100%, this is 1 means 100%. So let me convert this into 100% here. I'll just click in 100%, right? So wherever we have a sales equal to 100% means all the periods we have a sale. Every period we have a sale here. Look at August, we have a sale. August till somebody is joining. Let me. So every period we have a sale here. So these kind of products we can actually go for forecast because we are having consistent sales. If you have consistent sales means we have to stock them. If you have to stock them means we have to go to make to stock. If you have to make to stock means we have to go for forecast. But wherever we have inconsistent sales, inconsistent means intermittent sales, we can decide whether to stock or not to stock. If we decide stock, we have to forecast. If we decide not to stock, we will not forecast, right? So that is what we are trying to understand from here. Now, what I am trying to say is, if I want to understand whether we have a trend or we do not have a trend, right? So I'm going to understand that statistically here. So the formula I'm going to use is Corel. This is an Excel function, Corel. I'm going to select my sales here, entire sales from August till, this is 25 months period, 25 periods sales we have. Okay, this is my array 1. I'll take my second array, that's my time. You can put time also in the beginning. There's no problem for that. So now close the bracket. Now what I'm going to see is I'm getting an error here. Why I'm getting an error? Let's check that. Because there's no comma here. Let me remove this column, put comma. comma, close the bracket, enter. So now we see the values. So if you look at here, this is minus 0.23, 23%, right? So what we want, if we want to understand, if we have a very high trend, we need this value to be closer to 100%. If it is a poor trend, this value has to be close to 0%, right? If you look at 49%, it's 54%. As we see a higher value, it means we have a good trend. If we see a lower value, like 0%, 1%, 2%, 3%, 4%, we have a poor trend. Right? So this, by simple formula, by looking at the data, we are able to understand what kind of trend we have. At 67%, yes, we have a very high value of trend. Right? Now, if you see, there is a two signs here. Somewhere we see negative correlation, somewhere we see positive correlation. Negative correlation means our sales are falling down. Positive correlation means sales are going up. Okay, that's the meaning of the negative and positive. Now, if you want to understand the seasonality is, I'm going to use another Excel formula that is called forecast.ets.seasonality. Before that, I need to create another timeline that is called seasonal timeline. So we have the x-axis, which is called trend timeline. So I am going to create another timeline which is going to be used for the seasonality. So what I am going to do is that I'm going to create 12 months, a 12-month cycle data. This is 12-month cycle data. I'm going to create 12-month cycle data, another 12 months, and whatever is trending, we'll put 1. So this is my seasonality timeline. There are two timelines. One is trend timeline, which is going to be increasing period over period, and there is one seasonality timeline, which is going to have a cycle of 12 months because our data is we're going for month wise, right? So now I'm going to create my seasonality using my seasonal timeline. So forecast.ets.seasonality is an Excel formula, which is very simple formula. So I'm going to take the values from here. So this is my values, right? This is my values, and I'm going to take the timeline which we have, which we have to freeze it because the same timeline we're going to use for other items. So freeze means I'm going to put F9, F4. If you're using Windows, you have to click F9, F4. If you're using Mac, you have to click F9, F4. And do we have missing values? Yes, we have missing values, but we'll not go for that. I'll explain it later. So now if you look at here, seasonality is 0. It means the data suggesting is that we don't have any seasonality in this data, in this particular SQ. But if you look at here, the second data, we have a seasonality of 2 months. The fourth data we are seeing, we have a seasonality of 3 months. Of sixth, we have 4 months, 2 months, 2 months. So wherever we have a seasonality, it is going to suggest us we have a seasonality, right? So now, by using a simple Excel formulas or available Excel formulas, we are able to understand whether we have a trend or we have a seasonality. So once we know we have trend and seasonality, based upon that, we're going to decide what kind of forecasting model we require. Suppose here, if we have low trend, no seasonality. Low trend, yes, seasonality is there, right? So if you have a seasonality, we're going to use double exponential smoothing. So I'm going to suggest that what kind of model we have to use. Then after that, we'll go into the model which Ananya is working. So suppose if you have a data, with trend, we can use forecasting models like linear regression or double exponential smoothing. These are forecasting models which we're going to use based upon our availability of patterns. If we have a seasonality, pure seasonality, no other thing, we can use either moving average, or we can use weighted moving average. Right? There's various other models also we can use by transforming the data. It is ARIMA, SARIMA. We can also use time series decomposition. If you have trend and seasonality, you can use triple exponential smoothing. Or we can use TSD, that is time series decomposition. Or if you have a data with intermittent sales, means we do not have consistent sales. We can use Crosstown. We can use TSB. So most of the business we have, right, in most of the business, any company, any part of the world, they will be having mostly intermittent sales, right? So generally, what the mistake most of the sales people or the sales forecaster or demand forecaster they do is that they apply these methods, right? Moving average, weighted moving average, this kind of methods on the intermittent sales. So and they end up getting poor forecast, and the impact of poor forecast is either we have loss of sales, means we get an order, we don't have the inventory, or we get lower sales, means we have over inventory. Right? There are two problems with the poor forecast. Loss of sales, if we get the order, we don't have the inventory, or we are anticipating higher sales, but we are not getting sales, which results into over inventory. So these are the impacts. So this is what the major problems the forecaster does, because they don't know in which kind of patterns, what kind of forecasting models have to be applied. This is the biggest problem with the forecasters. So now, what the data which Ananya is working is, suppose we have a sales, right? And the sales is, let's say, we have a I'm using a random data generation. Guys, please feel free to ask the questions. So power, I'm using use a formula of power of 2, and here I'm going to use a random generator. Somebody wants to join, so let me add them. Okay, I don't see.
I just added.
Okay.
Push.
So this is my first data point, and this is working on the. Let me drag this. Some data. We have a good sample now. I'm going to plot this data. I'm going to draw a. Okay, so we have data like this. This is the first thing when we do forecast, we have to always plot the chart. By looking at the plot, we get some kind of understanding what kind of data we have. Okay, so now let's say this data doesn't look to me as there's a trend. Definitely, there's a trend inside. If you look at how can I say by looking at data there is a trend? So I can just plot a graph. This is a lower value, and this is a higher value, right? So what we can see, there is a trend. There's a lower value, there's a higher value. Definitely, there is a trend over here. Now I will see a peak here. This is a peak. This is a peak. This is a peak, right? And this is a peak. So do we see any kind of seasonality here? I don't think there is seasonality, because the distance between these two peaks are not same. This could be like fourth period, and this is our ninth period. So if you see, this is 5 periods. This is 9 period, and this is, let's say, 12th period. So the 3 period gap is there. Right now, this is 14 and this is 16. The 2 period gap is there. Right. So what we see here is there is the distance between the two peaks are not same. So I cannot see no seasonality here. This is by looking at the graph, I can actually decide my patterns. No seasonality. Yes, trend is present. This is my evaluation of the graph. Right. So now this is the same thing I will judge by using the Excel formula. Then we'll move into the So what I'm going to do is that I'm going to first create a timeline here.
Krish, one question. Can I ask or
Yeah.
should I wait?
Yeah, please ask.
Yes, so Krish, to arrive at the fact, whether we have trend or not, you drew the line from 1 to 16 time period. Should it not be from 1 to 17? Because 17th is the last time period that we have. And in that way, we would come to the conclusion that there is no trend.
See, suppose if you look at the current data, this data, because we have a random generator, so it is changing, right? Now, if you look at this one, this is our last data. Sorry, what? Sorry. This is your first point, and this is your last point, right? So we cannot see like this, right? There is a data between 1 and 17, right? So if we see from 1 and 17, we say there is no sales, or maybe there is a sale of 8 unit. There is a sale of 8 unit only. If you look at the first data point and the last data point, we'll say there is only a sale of 8 point throughout the period. That estimation could be a wrong because we are doing an estimation. We're not actually coming to a judgment, right? So what I'm doing is I'm doing an estimation, and that estimation is between. It could be between, right, a favorable starting point and favorable ending point. Favorable starting point and favorable ending point. But if I do this line like this, the first and 17 are same, so there is no trend. That estimation could be wrong. So I need to see a favorable starting point, and I have to see a favorable ending point.
All right, okay. I was just wondering that, saying that there is a trend would mean my sales volumes are increasing on a year-on-year basis.
Correct.
But we do see sharp falls as well.
Correct. Sharp falls also we are seeing, but there is more crests. There is more peaks.
Understood.
So that let's ascertain that by using a formula of correlation. So how much trend we have? So this is correlation. This is our x-axis, the time period, comma. These are y-axis, this sales, right? Close the bracket, and let's see how much we have. 24%, 25%. That's why we have a lower value of trend over here, right? Otherwise, we could have a higher value. 25% is a very small value of trend we have. And now we see seasonality. How much seasonality we have? So what I do? So now here look at this changing to 17%, right? So your assessment is that this is falling down. So VSE 17%. If I click enter once again, let's see forecast.ets. Seasonality, and this is my values. This is my timeline.
Should we not draw a separate timeline for the seasonality part?
Yeah, we can do that. Right? So let's see 1, 2, up to 12, and then we create new series. Right? So instead of now, what I'm going to do here is I'm going to change this to D10, D26. So now still the seasonality is 0. So we can easily say there's no seasonality in this because the gap between two peaks are not equidistant. That's why we're getting seasonality 0. And the trend component is minus 11%. So we have very poor trend. Okay. Now we'll try to forecast our using double exponential, and we're going to create additive as well as multiplicative forecast. So let's say our alpha is a formula for double exponential forecast. The formula for double exponential forecast. So I'll just write a formula here, and then we'll move into the model. So We say we are forecasting for period number t plus 1, that is the forecast, alpha into, we're going to take, there are three different formulas are there. 3 alpha into yt plus 1 minus alpha into yt minus 1 plus tt minus 1. What is alpha here? Alpha is your smoothing constant. And alpha can vary in between 0 to 1. So it should not be less than 0. It should not be more than 1. This is what we have to take into account. Okay. Similarly, we're going to forecast for trend t plus 1. So that is beta into, so this is yt minus 1 minus, yt plus 1 minus yt plus 1 minus beta into tt minus 1. Right. Again, beta has to be between 0 to 1. Means it should not be less than 0 or more than 1. Right. So once we have this formula, what we'll do now, we have for additive forecasting, we'll use ft plus 1 plus, ft plus 1 plus tt k into tt plus 1. So k is our, the period which we are forecasting. If we are forecasting for first period, it will k is equal to 1. If we are forecasting for second period, it will be 2 into 1. That's only the thing. And for this is used for future forecasting. If it is not for future forecasting, if it is not for future forecasting, simple tt plus 1 plus, ft plus 1 plus tt plus 1, if it is not for future forecasting. Multiplicative forecast, what we'll do, tt plus 1, ft plus 1 into k t plus 1. Right? This is for future forecasting. If it is not for future forecasting, what we will do, t plus 1 into, ft plus 1 into tt plus 1. These are the, these are formulas which it is very difficult for you to just grab it immediately as you're in the first session. But this has to be, when we model it, when we practice it, these formulas will be, we can grab it. Or if you do not want to learn or grab these formulas, so once you put these formulas into an Excel sheet, right, just have to create a model. You don't have to remember this. Only if you want to say that some kind of errors are there, if you want to check them, then you can go and check the formulas. Right? But you don't have to worry. Okay, this many formulas I have to remember to be a good forecaster. Nothing you have to worry like this. Once your model is ready, if you want to become an expert, want to become a good expert, then you have to have these formulas, either in notebook or in an Excel sheet or somewhere. Right? You can just review it continuously. As we are a trainer, so we are consultants, so we know we come into these formulas day in day out. So that's why we have these formulas in our mind. Right? But it's not necessary that you should have these formulas in mind. There's no problem. Only one thing you have to worry, your Excel sheet should have proper formulas. So any questions here, Anya? Because you are familiar with this thing, so, and you're working on this project. So do you have any questions how to use this additive forecast, multiplicative forecast?
So Krish, the formula that I had seen is slightly different. So when we are calculating the trend, we were using the level values instead of the Y values. So that's one of the things that I noticed.
Yeah, this is the level only. So this is a level value only, LT plus 1, LT. Okay, so let's go and model this in Excel.
And Krish,
yeah.
one more point. So we have taken the seasonality with a time period of 12 time periods. So is an organizer free to choose their own time periods? Like, can I choose that as 18 instead of 12 for my company?
Yes, you can choose. Suppose if your cycle is, you want to create a cycle with four periods. If you want to create a cycle with 3 periods, you can go to 1 to 3, 1 to 3, 1 to 3. You want to go with 1 to 18?
Okay, so
You can go 1 to 18, 1 to 18, 1 to 18, 1 to 18.
Okay, so what will be the business case, to have a time period of 18 months? And will that change my seasonality? So if I'm getting a value of 4 year, can it make that 6 or 8?
Yeah. So now what happens if you want to model this data based upon 18-month cycle, right? Based upon 18-month cycle. Suppose if you have a seasonality of 17 months, every 17 month, every 17 period it is increasing. Right? Suppose if you want to model it if you want to model it the time series timeline, you want to have a 1 to 18 cycle, 1 to 18, right? A cycle of 1 to 18. Okay. So now your what output you will get. Suppose if you have a seasonality of 17 period, every 17 period there is a peak.
Okay.
Every 17 period you have a peak. So what you get? So this means in a cycle of 18 periods, every 17 period you have a peak. But if you have a cycle, if you have a cycle of 112 periods, right? And if you say that every 8th period it is having a peak. Every 8th period is having a peak, for example. So 8th, then 16th, then 24th, right? So every 8 means this is 8, the cycle of 12, next 8, the cycle of 12, next 8, the cycle of 12. So 8, 8,
Okay,
8.
so the seasonality value would always be less than the maximum value of the time period that it
Correct.
choose.
So here if you're looking 8, 8, 8, 16, then last we go to 24, right? Then 32, then 40. So here you have a cycle of 17 and then 17. So you're seeing the 34th in the second period, second cycle. And you're getting the 34, we're not getting, 40 you're getting, and that we're getting in the 6th cycle. You're getting 34 in the second period, we're getting 32 here, right? This is 32. 5th cycle.
Yes, so the 34 over here would be 32 in the 5th cycle.
5th cycle. In between 5th and 6th cycle, you get 34. And you're getting the 34th in the second cycle itself.
Okay. So in a year we have 12 months. So why would someone want to have, a time period of 18 months?
Yeah, see, it is not, see, we have, suppose, the two cases we can think about like this. One case is that, he is planning his business. He's planning his business every 18th cycle. Right. Generally, what happens is we have a business plans which actually happens every 12 months. Suppose I have a company, and generally, globally, this is a routine that business plans are derived every year, right? Every 12 months. But somebody say, no, I don't want to go for 12 months. I want to go for 18 months. I want my plan, all my business plans every 1.5 years.
All right. Okay.
So I want to test my cycles every 1.5 years. Suppose somebody wants to understand, somebody wants to have the business plan is 12 months. And he's actually making a plan every 12 months. But he want to break that plan into 4 equal parts. Right? So this is 0 month to 3 month. This is 3 3 to 6, 6 to 9, and then 9 to 1, 2, 3, 4 parts. Right? So now he wants to, understand his business in 3-month cycle. Okay? You want to understand his business in 3-month cycle. So he can go to 1 to 3.
Okay, Krish, just curious. Okay, so say someone is in the business of ice cream selling. So we are going to see peaks only in the summer. So there is a clear seasonality of 12 months. Scenario like that, if the person wants to have a business plan for every 3 months, then he won't be capturing any seasonality because the maximum limit that I'm setting is 3.
Yeah, so in that case, he can make it data granular. He can make data granular. So in 1 to 3 months, what he will do, he will divide his data into week 1. So there will be week 1, week 2, week 3, week 4 for the first month. Right? Second month,
Okay.
he will have again week 1, week 2, week 3, week 4. Third month, he will again have week 1, week 2, week 3, and week 4. So now he has a cycle of 4 weeks. So now we have for 3 months we have
4 weeks or 12 weeks?
4-week cycle.
Okay, so the business plan is generating every 3 months. So that's why I was thinking 3 cross 4, 12 weeks is the
That also is possible.
business cycle.
That also you can do. If you want to go for 12 weeks, you can give a 12-week cycle. Right? This is another way. So there are 2 ways we can model. One is that you go with week wise in 3 sets, or you go week for 3 months, go 12 weeks. Then create a cycle of 12 weeks for 4 periods.
All right, Krish, but my seasonality would still remain 52 weeks. So can I capture a seasonality which is truly of 52 weeks?
And that
If my business plan cycle is 12 weeks.
Yeah. So if you are 52 weeks is your cycle, then you will capture seasonality by weeks, not by months.
Okay.
Right? If you are going with the 52 weeks data, right? With 12 weeks cycle, right? You're going with 12 week cycle for 52 weeks, right? And what you're going to do, you're going to capture your seasonality by weeks. Instead of months.
All right. Okay.
See how beautiful this is, right? The time period, the x-axis is a very important thing. It's a very, very important thing. How you have to, whether you want to go with the very granular information or you want to go with summarized information. Because it is, the time period which you choose is a very, very important role which you can play in your decision making. Either you want to go with the granular or you want to go to summarize. So you have to be very aware that what kind of forecast I'm doing. When I'm doing the forecast at the granular level, or I'm doing the forecast at the summarized level. That awareness we need to have. And how much granularity we need and how much summarization we need. Right? How much granularity we need or summarization we need for the forecast. That's a very, very important call. And this can be adjusted by experimentation. You have to do experiments by using proper reasons. If you experiment with proper reason, you will be able to understand your company's what kind of granularity you should set and what kind of summarization you need to set. Is it clear?
Yes, Krish, it's reasonably clear for me.
Okay, so now let's move towards the formula. So I have taken my alpha here. This is for our level smoothing or sales smoothing, and we'll take the beta for trend smoothing. Let's say I'm taking a random value here. Let me take a random value here, and between 1 to 10 divided, sorry, 10 to 100, 10 comma 100 divided by 100. Same thing I will do here, rand between. These are all formulas you will understand once you join a full training program. By 100. Okay, so we have a beta and we have the alpha. Now I'm going to create level forecast. And we're going to uppercasing this level and trend. We're going to create both additive as well as multiplicative forecast. Now level forecast. What I'm going to do here is that I'm going to take the alpha. First, the first forecast will be, let's take the average. We start the forecasting from the second period. This is the first forecast, okay, and this is level forecast. Now I'm going to create trend forecast. Trend forecast, I'm going to do the subtraction between the first value, second value minus the first value. This is the first forecast, and we're going to apply our forecasting from the second value. Now alpha, what is alpha here? 0.56. I'm going to freeze this number because I'm going to use this alpha for the rest of the forecast. Alpha into sales, okay, plus 1 minus alpha. Again, I have to freeze this alpha into the previous forecast, that is G10 plus H10. I'm going to put them into brackets. This is, I'm getting a forecast over here. So this is what our H8 into H8. What is, let me double click on the formula. Yeah. So H8 now. So H8 is what? H8 is our alpha into F11 is what? Our sales plus 1 minus H8, that is 1 is minus H8 is again alpha into G10 plus S10 is our previous level and trend. Okay. So now I'm going to drag this formula till last. I'm now going to forecast the, so simple, right? The first forecast we have to do. Everything is taken care from there. Now I'm going to do the forecast for the trend. So what is beta here? Beta is 0.38. I'm going to freeze this into what is my level minus, right? This is this minus this, right? Plus 1 minus beta again. I'm going to freeze this into the previous forecast. What I'm going to do, I'm going to freeze these values now. I just don't want to change it continuously. Just copy, paste special. Okay, so this is our level forecast and trend forecast. Now I'm going to create additive forecast, additive final forecast. Let me take it to the right hand side. What is additive final forecast? This plus this. We're not doing future forecasting, right? And what is a multiplicative forecast? going to multiply level into trend. Okay, clearly we're saying the multiplicative first forecast is a bad forecast here, because this is not a data which is having a multiplicative. Now, if I want to do the future forecast, you want to do the future forecast. So, what is the period number 18? For example, I want to do forecast for period number 18. So, what is my additive forecast here? In that case, it will be the previous level plus, let me freeze this, plus the K, this is my K, into the previous trend. I want to freeze this. Now I'm able to do the future forecast. Right? Future forecast. Same thing I can do here also. So this is my previous level forecast. Freeze this into 18. This is my number which I am going to forecast into the trend. This is my future forecast. So there is some problem. I think I didn't freeze some value. So E26 I have to, okay, S26 I have to freeze. Right? Let me fix this value now, 0.4. Let me put this as 0.5. Six. 0.8. Okay, so this is how we are able to use this data to create our additive forecast, multiplicative forecast for future as well as the same period. Since this data doesn't have a huge trend, this have a negative trend. It means the sales are dipping down. That's why we see negative values. Sales are dipping down. Seasonality is 0. This is a perfect double exponential smoothing case. So we are seeing the sales are dipping down because we have a negative trend. That's why we are seeing negative values over here. Look at here, 256, 16, 2, sales dipping down here, right? Sales are dipping down, so that's why we have a sales, we're getting a forecast value which is also dipping down. So additive model, where we are just adding the level and trend. For the future forecasting, we are bringing a new component that's called K, and the K is called the time period. For 18 time period, 19 time period, 28 time period, right? That is what we have a formula K. So whatever we have the for level forecast plus K is 18 period, 19 period, 28 period. Whatever is the period that we have to put over here into the trend forecast. So I'll just try to repeat what we have done. So we have taken the time, this is our seasonal timeline. This is our trend timeline. We need to have two timelines when we do time series forecasting. Seasonal timeline, trend timeline. Okay. Then we have a sales. So what we did first, we tried to check our trend, how much trend we have, right? And for that, we have used formula for Coral. And this Coral is giving us a formula, output minus 46%. This means we have a negative trend. Negative trend with 46% correlation with time. Correlation of sales with time. Right? Then seasonality is 0, means we have 0 period seasonality, means there is no seasonality. This is what the output we got, right? So when we have a trend, in the data, whether it's positive trend, negative trend, it doesn't matter. We can use a forecasting model, double exponential smoothing. Double exponential smoothing, because we need to understand whether we have trend or not. If we have a trend, then we have to use this model. So that is what we are using as double exponential model. What is double exponential model? Double exponential model is alpha into yt plus 1 minus alpha into yt minus 1. So this is why, okay. So this is what we're using here. Beta, and for trend forecast, we're going to use beta into LT minus 1 minus LT plus 1 minus beta into TT minus 1. So alpha has to be in between 0 to 1, beta has to be between 0 to 1. It means alpha cannot be less than 0 or cannot be more than 1. Beta cannot be less than 0 or cannot be more than 1. This is what we need to take care. We should not put any value alpha as more than 1. We should not put any value alpha less than 0. Means negative value. We shouldn't put it. In between 0 to 1, we can put. We can put either we want to put 0, you can put 0, you can put want to put 1, you can put 1. But should not put more than 1, less than 0. Same thing applicable for beta also. Now we are going to forecast alpha and beta, and then we have to decide whether we want to go with additive forecast or multiplicative forecast. We should not go with both the forecasts, because we know by looking at the data, we can easily understand whether we need to go to additive or multiplicative, either of them. So if you want to go to both of them, you can create a model with both of them and see the accuracy of the model. And that accuracy we can actually see by using a formula called MAPE. So that's I'm not going to build over here. MAPE. MAPE is what? MAPE, or we can also use a formula called median. MAPE. Median. So M stands for mean, means average. Average means mean absolute percentage error. Median absolute percentage error is, we instead of taking the mean of the error, we'll take the median of the error. We can also go for the root mean square error. We can also go, this is RMSE, root mean square error. You can also go with RMSE divided by mean. RMSE by MAD, mean absolute deviation. Or we can also go with a new formula, RMSE divided by MAP. So no, only MAD, not MAP. Right? So we can create so many metrics and we can evaluate our forecasting model, how good it is. Guys, so I want to give an opportunity for question answer sessions before we wrap it up. We have another half an hour to wrap it up. So I would like if you can ask questions, so I will be able to answer them. Hi team, are you there? You have any questions? Means if you want to, like questions, if you have any questions, any challenges which you face with your company data, with your current forecasting model, anything you can ask. So are you guys comfortable with the English? Means is English is something very easy for you guys? Comfortable with? Are you guys? Am I audible to guys? Hello. Are you there?
Yes, Krish. We can hear you. I can hear you.
Okay. So any questions, guys, from your side? Any questions, please ask. So here there is one more forecasting model we can use if we have a trend, right? So I discussed in the beginning that we can also use linear regression. So here I'm going to use linear regression. That linear regression is we're going to use a formula called forecast.linear. Forecast.linear. Now, what is X here? X is our this. What is Y? Y is our sales. I'm going to freeze this sales because this has to be, we have to use the same values all across. And what is our time period? We have a time period is this. Again, we have to freeze this time period. Okay, then close the bracket. So this is our sales, which we're getting 491 units as a forecast. I'm going to drag this. Okay, so if you see 491 is the sales, 460, 430, 400. So if you look at here, it is dipping. If I plot this data, if I plot this, see the sales are dipping here, right? This is our y-axis sales, and our time period is the x-axis, and it is dipping down. Why is dipping down? Because our trend is negative. Trend which you got is negative 46%. Negative 46% means the sales, the forecast has to dip down, fall down. The forecast has to fall down, means our forecast, our sales will be dipping down. That's the reason why we're getting a forecast which is showing in a continual decreasing trend. 491, 460, 430, 400. Then 400 to 370 means there are 30 units less in the fifth period, then fourth period. And if you look at sixth period is 339. The fifth period is 370. So again, this sales are dipping. 309, 279, 249, 218. So sales are dipping consistently. From 491 for the first period forecast, we reached to 7 units for 17 period forecast. Right? So now we have to make a selection. Shall I go with the double exponential smoothing? Shall I go with the linear regression? Right? We have to make a decision. So I see a better model of linear regression because I am not seeing any negative values here. Here there is a negative. Negative value means we have to keep zero inventory. Wherever you see negative value, suppose this is a negative value, minus 489. If you see a negative value, it means we should not have any, we should not order anything for this month. So wherever we have a negative value, suppose we have, I'm going to create another dimension here. So if this is more than 0, more than equal to 0, then I'm going to say take the same value, or else it is 0. If it is negative value, I don't need to forecast anything. Wherever we get negative value, we'll say 0. This is minus 50 or something, you get 0. I don't want to do any forecast. I don't want to have any inventory wherever we have a 0 forecast. Though this model is not good, the outputs which you're getting is not good. There's no doubt about this, right? Output we are getting is not good. But at least wherever we see how to interpret a negative value. If you get a negative forecast, it means you do not need to, buy anything or do not need to produce anything for that particular month. So for the fifth period, I'm not going to produce or buy anything. For seventh period, I'm not going to produce or buy anything. For ninth, every alternate period, what we're seeing 0 here. Because we have a negative forecast. So this is how we interpret the negative values in the forecast. And if you see the linear regression, we don't have any negative value anywhere, but what we see, the sales are dipping. Now see, there is its high value over here. 256 is a high value. I change this 256 to 20. I change this from the 20. So now still we're getting 440 as high. Now let's say I will make it as 0. Again, we're getting 435 to 32 here. So it was an original 2025, right? Let's put this again. There is not a much impact we're getting if we change our first value. So the the reason why we're getting very high sale is because of these two values, and 1024, 1024, right? This is an outlier. This 1024 sales are not happening consistently. If you look at the sales of this entire data, let me plot this graph also. How we can improve the forecast, right? There are these 2 points. This is the area which is a problem for us. This is the area which is a problem for us. Look at the sales of rest of the data. This is over in this area. This is the area where we have a problem. If I remove this problem area, I'll make it, suppose, what is the average of the sales? Let's say 200. I'll replace these values with 200. Now look at our forecast is improving. Our forecasts are coming very, very almost close. Just because of this 4th and 5th value, which was an outlier, it's an outlier. What we did is we removed the outliers. After removing the outliers, we can see a very good level of accuracy in your model. So those are the different techniques which you need to work on: data cleansing, data transformation, all those things that we can do in the Power Query itself, and that process can be automated. Okay, so this is how. So I'm making this data back to what it was earlier, 1024 and 1024. This was the data which we had earlier. So I'm making it back because I just wanted to show you how this forecast can be improved by replacing your outliers. Into, this is the problem area for us. Once again, I show the problem areas. This is the problem area. Rest of the sales are happening in between this area, right? The entire sales are of our entire sales are happening in between these two areas. Just for this period, we have these 2 periods are rare events. Rarely we see those 2 events. So shall we predict the sales based upon the rare events, or shall we predict sales based upon the frequent events? So if you incorporate the rare events into the forecast, that will be a problem for you. If I remove this rare events and replace these rare events with frequent events, then I think we can have a good forecast. If you forecast with the rare events into the model, then you can either land up incorrect forecasting. But this will not happen every time, unless it is a seasonality. This is how we are forecasting with double exponential smoothing and linear regression. The 2 models we have seen. Within double exponential smoothing, we saw 2 models. One is your additive, other is multiplicative, right? And within the linear regression, another thing is we have seen the linear regression, right? Now, I will show you another method. We have 20 minutes left. If you have any questions, please free to ask. I will stop and reply to your questions. I'll use another technique now called categorization of data. Suppose I have a timeline here, 1 to 12, 1 to 12. Okay. Or we have something like here, 17 periods over here. So what I'm going to do here is that I'm going to create a category. I'll say T1. So I have 12 periods. My first period will be 1. I'm going to create a category here for 12 periods. I have 12 variables now. This is my January month. Let's say this is January. This is February. Now, the second period, I'll create again. The rest of the little I'm just use a formula now. This is equal to 5, give me 1, or else 0. Wherever we have a 5, we'll get 1. Rest of the value will be 0. Right? This is 5. Now I'm going to get another formula. This is equal to 6. If this is equal to 6, give me 1, or else 0. If this is equal to 7, give me 1, or else 0. If this is equal to 8, give me 1, or else 0. If this is equal to 9, give me 1, or else 0. Right? Wherever we have 9, we're getting 1. Rest all are 0. If this is equal to 10, give me 1, or else 0. Where we have 10, the corresponding value will be 1. So this is 1, this is 10. And where we have 11, if this is equal to 11, give me 1, or else 0. Right? So we have 1 over here because that's 11. So now we have a data with sales, and we have 11 variables, transformed variables, which are categorical variables. The definition of categorical variables means where we have only categories. So we have 1 or 0, 1 or 0, 1 or 0. The two categories, either 1 or 0 or 1 or 0. Now, if you see, sales is my output variable, and I have 11 input variables. Okay, what I'm saying here is sales is equal to outcome variable, which we have to use to predict our sales, right? We have to predict our sales for future using 11 time periods as our input variable. Previously, when we did a linear regression, we had only one input variable. Now what I did is, instead of going with one input variable, I'm going with 11 input variables. So what I'm going to do now with this, sales is our output variable, means we have to predict our sales using 11 input variables, which are time period. So for this, I'm going to use another method which is available in Excel, that is data. Go to data analysis and go to regression. Click OK. And this is my multiple regression. I don't know whether it will allow us to use 11 variables, but let's check that. So input Y range. What is input Y range? Sales. Sorry. Yeah, input Y range means our Y range is sales. That is our output variable. What is our input X range? That is our 11 time periods. Okay, and we have a labels. Labels means name of the cell, and we want to output in a new cell. I'll take plots and click OK. So Excel is processing and will give us the output. Right. So if you look at the output, There are two things we need to see very strong. One is the R square, other is the adjusted R square. Okay, R square is very strong. That is 71%. It is, if it is closer to 100%, we have a very strong model. Means our input variables are able to predict the output. So whatever variable we are selecting to predict our output, if this value is high, means we have very good input variables, which is able to predict our output. But the other thing, if you look at adjusted R square, this is 7%. It means the input variables which we have is overfitting the model. Means we have same kind of model, same kind of variables which are available in the model. So this value adjusted R square is a good predictor to understand whether we have same kind of variables adding up to show that we have a good model. So there are redundant input variables are there. If this value comes down from the R square value, 71% to 7%, means the input variables which we have, they are redundant. So we need to select lesser number of variables. That's what we have to see from this particular output. But R square is very high, 17%, means we have very good input variables. But those input variables are of similar nature, maybe collinear. Because of the collinearity, they're adding up and showing us, yes, we have very good variables. But that's not the case. We need to eliminate some of the input variables. That's what this is suggesting. Now, the third thing we have to see is significance, model significance. This is 48%. This should be less than 0.05. If you want to have a good model, then this value should be less than 0.05. We don't have a good model as of case because it is showing significance of 48%. Means it is saying that the model is not very, the output which we are going to get will not be accurate. The outputs, the forecast output which we are going to get will not be accurate. If this value could have been less than 0.05, we could have said a model which we are building could be very accurate. So this adjusted R square is also telling the same thing. Model is not accurate. This is also telling the same thing. The model is not accurate. Now, if you look at the next thing is over here, p-values. This value should also be less than 0.05. If you look at here, this is 73, 65, 5, 92, 59. Only one model, which is only one predictor is showing. Only one predictor showing this is good. T4 is only good. Just all the values are more than 5%. So none of these values are good. We're going to eliminate all the T5, T6, T7, T8, T9, T9, 11, T1, T2, everything will eliminate. Just we're going to use T4 as our input variable. Because rest all are showing more than 5%. Whichever variable p-value is less than 5%, that has to be picked for the model evaluation. Right? So with this 11 predictors or 11 input variables, if you go for forecasting, we are getting a very high level of significance, means very poor model, because this has to be less than 0.05, means 5%, but if we're getting 48% here. What I want this to be less than 5% or equal to 5%. That's why the model is not accurate. Right? And now if you see here, getting a forecast, and we are 225 is the first forecast, 16 is the second forecast. See, you're just directly getting a forecast over here. 256, 1024, 520, 512, 464. This is your forecast. This is your error. Directly you're getting the output over here by using this model. And what is the forecast model? The forecast model is equal to, if you want to understand what is a model, the model is equal to, this is what? Where is the model? Yeah. So this is a model, 52.8. This is your intercept. This is coming from here. Plus 172.2 into T1, whatever is the T1 value, right? Minus 36.8. Into T2. This is coming from here. T3. T3 has 203.2 into T3. Like this, we can build a model or forecasting model. But this is clearly suggesting we don't need T1, T2, T3, T4. We just need T4. We just need T4. Rest all are very, very high. Even if you go with T5 also, you can go T5. But just T4 or T5 is enough. So I'm going to remodel this. I'm going to create remodel. So in this remodel, my input variable will be, I'm going to remove my inputs X range. I'm going to take only T4 and T5 inside this. Let's see what happens. T4 and T5. I'm going to create the model now. See, this has significance is improved. This is less than 0.05. Look at the adjusted R square. Previously it was 7%. Now it is 42%. Previously it was 7%. If I show the model, see, it was 7% here. It has to be closer to 1%. So as soon as we have removed other variables, it has become 42%. This was 45% in the previous model. See, 48% in the previous model. What we wanted is less than 5%. Now, if you look at here, this has become, this is what we want. 1%. You wanted 5%. Now it is coming as 1%. So the model is very significant. We have a model which can give us very good accuracy. Now look at T4 and T5 p values. All are less than 5%. We wanted these all values to be less than 5%. And we got only one. T5 is 8%. Okay, that's good enough. Okay. Now we got a model which will be having a lot better accuracy. And what is the model now? What is the equation of the model now? The model equation now is, it's a very simple model now, which previously we had such a big model. Now we have a parsimonious model. Parsimonious means a smaller model, a clear, simple model. So 152.92, it is coming from here, plus 871 into T4, plus 367 into T5. Simple model. After elimination of some of the variables, because the variables were not adding any value, so whichever variable is not adding value, we have removed them based upon the p-value. P-value has to be less than 0.05. So in the previous model, wherever we saw the p-value is more than 0.05, see all these models, 73%, 65%, 92%, we have removed all of them. After removing all of them, we got only two variables, T4 and T5. But now we build a very simple model with higher accuracy. So this is another way of time series forecasting. So what we did, we had an initial data. What was initial data? This was initial data, right? This was initial data for us. This is timeline, seasonal timeline. This is sales timeline. This was the initial data. Then what we did, we converted this data into this form. We have 12 seasons. We built 11 variables. After this, what we did, we went to data. We go into data analysis. We choose the regression. We click, and here we have chosen our Y range. Y range is our sales. X range is the variables T1 to T11. Then we are selecting the labels. Labels means we have names for each column. And then we are setting good new worksheet, new all these plots, and clicking OK. And that we're getting the outputs in this two form. And how we are evaluating this output? We're evaluating this output based upon R square and adjusted R square difference. Right. The first thing we have to see the difference between R square and the adjusted R square. Look at the difference. 71% to 7%. This is clearly telling me we have an extra variables which are not required. Okay. If this R square and adjusted R difference is less, it means we have a good model. This is difference. There's a huge difference, means we need to work on the model further. Second thing I'm looking at is significance, model significance, overall model significance. This should be less than 5%, but we are getting 48%. This is second indication your model is not good. Third indication, we go to p values. This should be also less than 0.05, means 5%, less than 5%. So whichever is less than 5%, we'll going to pick from there. This is less than 5%. I took T5 also because this is closer to that. If I want to eliminate, I can eliminate T5 also. So this is suggesting me that don't take T1 to T1 to T3 and T5 to T11. Just only pick T4 because this is the only variable which is showing less than 5%. But what I did, I wanted to take T5 also because this is showing 14%. Then I took T4 and T5 together. Okay. Then I build the model again. And in this, if I look at here, the difference between the first thing, R square and adjusted R square, is only 7%. It's 49% and 42%. So this is showing us that we have good number of variables. Whatever variables we are selecting is good enough. In the previous one, we had a big difference, 17% to 7%. But here you see 49% to 42%. Now the second thing I'm saying is this should be less than 5%. This is good enough for me. Now I have to see this thing, p value here. Only thing T5 is greater than 5%. If you want to eliminate T5, you can also eliminate T5. So this is how I built a multiple regression model by transforming the time series. We have to study all the residual plots also that we will see later on. So just I want to give opportunity for question answer session. So any questions you have, guys? Ananya and all the team from the Mongolia. If you have any questions, please ask. I know this is in the first sequence. This is the first exposure to the data and analytics, and so it will be tough for you to understanding. But I assure you that if you go with the process in a structured way, you will learn a lot of things, and you will be able to grab these things very easily. Since you are actually getting, I don't know what is your exposure. If your exposure is very high to data and analytics, then I think you will be able to grab this very easily. But if your exposure is less, then you have to go through the structured training. Then once you go to the structured training, then you will be able to grab all these concepts very, very easily. Ananya is already exposed to this thing, so he can actually get all those things very easily. So Ananya, you have any questions here? How the transformation worked? How we actually, eliminated some of the variables and created a new forecast?
No questions as such, Krish. Just that if you can share this file also with us. So I'd like to do some of the things hands-on that you did on the screen.
Sure. I'll be definitely sharing. I'll putting this file inside the Teams.
All right. Along with the recording as well.
Yeah. Recording will be there already.
Sure.
So guys, any questions from you? Please feel free to ask. So I see. I don't know whether I'm able to spell the name properly. There's I'll be looking at names like Amarzaya, Aryuk, Ink Buyer, Ink Ikna Moon. I know because I'm not able to spell the name properly. Please don't feel bad. Khaliyuna, Khantanul, Khantantul. So guys, are you there? Are you able to get something from this training program? So if you feel free to ask your questions.
If we have that the same sheet with the formulas, we will use our data and we'll try to do same forecasts.
Great, great. So I'll be sharing the template to the training manager with, so you can collect the data from the training manager.
Thank you.
Okay. So any more questions, please? So I think the training manager is Kantan tool, right? So please, I'm not able to spell your name properly. Please don't mind. Please don't get offended. Okay. So okay, I'll be ending the session for today, and I will be sharing the video recording and the template, the Excel template to all of you. I will be sharing this template and the video recording to the training manager. And Ananya can access the video recording from the Teams, Microsoft Teams cloud platform, also the Excel from the Microsoft Teams platform. Right, Ananya, you can access from there, and that's
Sure.
all. And I will be sharing it data with the training manager, which I'm already in touch with on their email. And if you have any questions, you are free to ask the questions over the email also to me, and I will be replying back. So we can keep our engagement even after the program. So don't think that this is one training program and we are losing our engagements. So you can keep engaging with me if you want to ask any questions, and I'll be sharing. My email ID is already with the training manager, so she will be coordinating with all of you. So please feel free to share your questions over the email later on. So I'll help you answer those questions also. Right. So keep engaging with me. So don't think that this is our first and last interaction. So I'll be helping you guys. Okay. So I am closing this session, and if you have any questions, then we can connect to the training manager. Thank you very much for attending. I am grateful that you people have shown interest and took part in this session. I'm very, very grateful to you.
Okay, thank you very much.
Okay, thank you very much, guys. Have a good day, and
Thank you, Krish.
have a good year.
You too.
Yeah, bye.
Thank you, you too.